Welcome back, viewers on YouTube. In this video tutorial, we are going to consider proving the derivative of tan x. So let's state the derivative of tan x first. It says that if y is equal to f of x and f of x is equal to tan x, then the y dx, which is the derivative of y with respect to x, is equal to secant squared x. Perfect. So now let's investigate. Let's prove the formula. Let's prove why the derivative of tan x is equal to sec squared x. Perfect. Now, from definition of derivative, the y dx is equal to the limit as h approaches 0 of f of x plus h minus f of x all divided by h. Now, from our knowledge in trigonometry, we know that tan x is absolutely the same as the ratio of sine x to cos x. Now, since tan x is f of x, then what would be f of x plus h? Since f of x corresponds to sine x over cos x, then f of x plus h will be equal to sine of x plus h divided by cosine of x plus h. Now we have everything we need to substitute for the definition of derivatives. So therefore we can continue finding the dy dx of tan x. So this will be equal to the limit as h approaches 0. Now f of x plus h, we got that to be this. That will be sine x plus h divided by cosine x plus h, then minus f of x. This is f of x. Minus f of x, that's sine x divided by cosine x, then entirely is divided by h. Now, as you can see, this is a compound fraction. So let's begin by simplifying it to the simpler form. So first, I will combine the numerators. So the LCM will be cosine x plus h times cos x. So therefore, we now have, okay, let me write under it, the limit as h approaches 0 of, so if the LCM is cosine x plus h times cos x, now what will be the corresponding numerators? Now cosine x plus h in this entire expression, we are left with cosine x, and we multiply with this, we have sine of x plus h multiplied by cosine x, then the subtraction sign is still there, minus. Now we have these in the entire expression, we have cosine x plus h. So we have cosine x plus h multiplied by sine x. Perfect. Now the h, that will be multiplied by 1 over h. As you can clearly see, it will be, we're just trying to flip it. It's divided by h, so it will be times 1 over h. Perfect. Now let's multiply this. Now this will be equal to the limit as h approaches 0 of sine x plus h times cosine x minus cosine x plus h times sine x. Then everything is divided by, so the product of this and this, that's cosine x plus h times cos x, then multiplied by h. Perfect. Now at this point, we need to expand the sine of x plus h and cosine of x plus h. And to succeed in that, we need to revise some of our trigonometric identity. And this is the one we'll be considering using. So the sine of two angles is equal, the sine of the sum of two angles is equal to the sine of the first times cosine of the second plus the cosine of the first times sine of the second. Similarly, cosine of two angles, typically the sum of the angles, is cosine of the first times cosine of second minus sine of first times sine of second. So if that is the case, it's easy for us to simplify sine x plus h and cos x plus h. So therefore, we have the limit as h approaches 0. Now sine x plus h, that will becomes sine x cos h, then plus cos x sine h, and don't forget outside it we have cosine x. Perfect. Okay, I've used this identity. So the next thing is to use this one to expand cosine x plus h. So we have minus. So cosine x plus h becomes cosine x, cosine h, the minus sine x, sine h. And outside it, we have sine x. Perfect. And as you can see, everything entirely is divided by cosine x plus h times cosine x times h. Perfect. Now, what I would like to do at this point is to expand. Let me distribute this cosine respectively and this sine respectively at the numerator. We have the limit as h approaches 0. So cosine x times sine x cos h. That will be sine x, cosine h, then cosine x. Then cosine x times cos x sine h. That will be positive cosine squared x times sine h. You can see cosine x becomes squared cosine, and we have sine h beside it. Now minus, before it takes effect, let me put it outside first. Then let me put this in bracket because the minus is expected to do something. So let me expand. Sine x times this expression gives sine x, cosine h. Perfect. Then sine x times this entirely gives us minus sine squared x, then sine h, close the bracket. And we'll see how the division of cosine x plus h times cosine x times h. So recently I'm out of space, so I need to flip onto the next page. So let's continue right now. So let me shift that a little bit forward so you can clearly see the logic. Perfect. Now the y dx will continue to now be equals to, now let me distribute this minus sign, the minus. Okay, perfect. Now we have sine x, cosine h, cosine x plus cosine squared x sine h. All right, the minus, when the minus multiplied this, we have minus sine x cos h. Okay, the minus times minus this gives us plus sine squared x sine h, and we'll see our division of cosine x plus h times cosine x times h. Perfect. Now as you can see, these are like terms, they can absolutely cancel out. Okay, sine x cos h are like terms, we can cancel them. Then we can combine this. Then we have the y dx. Okay, I forgot the limit, so the limit is there. The limit as h approaches 0. All right, then we have cosine squared x sine h, then plus sine squared x sine h. Then we have the division of cosine x plus h, then multiply by cosine x times h. Perfect. Now we are through with this. I can get rid of it and move forward a little bit. Perfect. Now proceeding forward, what I would like to do at the numerator is I would like to factor out sine x. As you can see, we can find it at both sides. So we have to be equal to the limit as h approaches 0. Taking sine h outside, we have sine h. Left over is cosine squared x plus sine squared x. Then entirely is division of cosine x plus h times cosine x times h. Now at this point, we still need to use one of our trigonometric identity, which is simply the Pythagorean rule. As you can see, the square of the sine of a particular angle plus the square of the cosine of that same angle results in 1. So therefore, this entire expression will be nothing but 1. So therefore, we can proceed forward and have the limit as h approaches 0. 1 times sine h is sine h, all divided by cosine x plus h times cosine x times h. Now what I would like to do at this point is that first I would like to take cosine x outside the limit, as the limit is such that it's with respect to h, And cosine x has no business with h. So therefore, we can have 1 over cosine x to be multiplying the limit as h approaches 0 of sine h entirely divided by cosine x plus h times h. Now, this is limits of product. We can absolutely turn it to the product of limit. But before we do that, let's break this expression into pieces. Now we have the limit of 1 over cosine x multiplied by the limit as h approaches 0. So what I'd like to do is that I will attach the h along with sine h, while I will split cosine x plus h outside. Then we have sine h over h multiplied by 1 over cosine x plus h. Perfect. Now we can distribute the limit. Then we have the y dx equals to 1 over cosine x multiplied by the limit as h approaches 0. Okay, that will have to be in a bracket because of the cosine. H approaches 0 of sine h over h multiplied by the limit as h approaches 0 of 1 over cosine x plus h. Incredible. Now we can plug in the limit as h approaches 0. But what we need to know is that the limit as h approaches 0 of sine h over h is indeed equals to 1. Okay, it's the measurement of small angles. Okay, you can confirm that with your calculator. If you plug in a value that is closer to 0 into this expression, you should end up with 1. All right. Now you can plug in something like 0.00001 and just find the sine of this angle and divide it by that value. You should end up with 1. But keep in mind, let your calculator be in a radian because you are measuring very, very small angle. Okay, perfect. So if that is the case, this expression entirely becomes 1, and 1 multiplied by this gives us this back. So we have 1 over cosine x times the limit as h approaches 0 of 1 divided by cosine x plus h. Perfect. Now we can plug in the limits as we can't have an undefined function, and this equals 1 over cosine x, then multiply by, as h approaches 0, we have 1 over cosine x plus 0, and proceed forward, we have 1 over cosine x times 1 over cosine x, because x plus 0 is still x. And this product gives us 1 over cosine squared x. Perfect. Now, at the end of the day, the y dx will now be equals to, now this is a reciprocal of the cosine function, and the reciprocal of cosine function is simply the secant function, and since it's squared, it gives us secant squared x. And this is how the derivative of tan x is equal to secant squared x. I hope you now know how the formula is formed. And also, if you have any question, feel free to let me know in the comment section below. Thanks for watching. See you in the next video. Bye for now.